Welcome to this edition of Momentum. I'm your host, James Warnock. My first guest today is Dr. Cindy Bethel, who's an associate professor in computer science and engineering and the director of the STARS Lab. So Cindy, thank you for joining us today.
I'm glad to be here.
And STARS obviously is an acronym. You're not doing astrological research. So what does STARS actually stand for?
It's the Social Therapeutic and Robotic Systems Lab.
Okay, social, therapeutic, and robotic. So in simple terms for people like me, what exactly do you guys over there do?
We do research related to how humans are going to interact with robots, basically. And so we're looking at it from different application areas, including gathering information from children, using robots for therapeutic purposes for people who've gone through post-traumatic stress disorders. We also integrate robots in with tactical teams and our SWAT teams.
Wow, that's quite a varied application there. And you've brought one of your friends with you today. This is Now?
This is the Now robot, yes.
Okay, and what's Now used for? How's he used in therapeutic
We've been using
situations?
Now to gather information from children. And so he is acting as an intermediary in a room with the children, and we use him to interview them to gather information from them. We've been doing it based on eyewitness memory and also on their experiences with bullying.
Okay, and the children presumably respond very well to the robot?
Yeah, they see him as a friend. Some of the children have commented that they feel they can tell him things they can't tell other people. They feel that the robot is non-judgmental, so that they can tell them things and not worry about having a human judgment on them. So they feel very comfortable sharing information and talking with the robot.
Okay, and he's standing here, he's moving around, he's moving his head and his arms slightly. Does he speak to the children as well, or is it a one-way dialogue, or how does the robot interact with the child?
He actually speaks with them.
Okay.
And so we have him speak to them, and then they respond, and then we have somebody behind the scenes that's actually producing kind of the interactions that come from him to the children. So it's a very personalized engagement. Okay,
so it's not like when I'm talking to Siri on my phone and it's almost like canned responses to my questions. There's actually an operator that interacts in a much more personal way.
Right. So we have some things that are autonomous, like its movements are autonomous. Some of the things it says it does, it's pre-programmed and will do, sort of like Siri. But we actually have someone who can type in responses so it can be more personalized and that we can provide more interactions and a better engagement.
Okay. And the voice, is the voice a human voice, or,
no,
or does it sound like a robot from a sci-fi movie, or?
Somewhere in between.
Okay.
It sounds childlike, but it does have a little bit of an electronic quality to it. And I'm sorry I didn't have it programmed to speak today, but it has sort of a small, probably 4 to 5 year old child voice on it. And it's kind of non-gender specific.
Okay. And I mean, this is fascinating. I'm just kind of mesmerized by him moving around next to me. How do you get the movements? Is it reactive to light or to movement, or? The
mode that he's in right now is called aliveness. And so he's got sensors in his ears so he can orient towards sound. He has light sensors in his camera, which is actually what looks like his mouth and not his eyes. And so he will fixate on different people based on that, and then when he locks onto a person, his eyes will actually change color to say, I'm tracking you, and so he tracks their faces.
Okay, so that explains why he turns towards me when I'm speaking, then he turns back to you when you're speaking.
Right, because his sound localization is orienting him towards where the sound's coming from.
Wow, that's fascinating. And where are we in terms of I don't know if this has to go through sort of approval processes, or are these therabots being used in court cases now, or are they being commercialized, or where are we with the technology? Okay, we
were funded by the National Science Foundation to do this research, and we're still in kind of the early development phases. We're doing a lot of studies. We've conducted 3 years worth of user studies with children ages 8 to 12. So we're still in that process of gathering information. We hope eventually to be able to bring this into a court setting or into a more legal setting so that it could be used in gathering information for legal cases with children. who've gone through maltreatment or any kind of abuse.
Yeah. Well, this is absolutely fascinating. It's been a real pleasure having you on the show today. Good luck with all the future research and everything else that you do. And I'm looking forward to hearing more advancements with this.
Okay.
We're going to take a quick break now, and we'll be back in a few minutes with our next guest.
Everyone remembers their favorite teddy bear, the reassuring love of their first puppy. They comforted us and made us laugh. For children battling abusive situations or post-traumatic stress disorder, the memories aren't as pleasant. That's why at Mississippi State University, we're pioneering a robotic technology that brings healing to those exposed to traumatic situations. Known as Therabot, MSU's robotic beagle includes lifelike features that allow it to move in ways that are both natural and nurturing. Its ultimate goal? To bridge the gap between two types of effective therapy, using real animals and their plush counterparts for emotional assistance. At MSU, we're proud to be changing the game in therapeutic recovery, even prouder to be putting lives back together again. What drives you? What pushes you forward? Is it an appetite to be the best? Or a calling to make a difference? For those of us here at Mississippi State University, it's both. We're designing a future where cutting-edge hybrid technology isn't imported from overseas, but exported from our own backyard. We're working toward a day when solutions to energy independence move at 0 to 60 in 5.5 seconds and are as simple as charging a phone. A day when fuel economy and environmentally friendly are viewed as less of a compromise and look more like this. For us, turning heads in the auto industry is great, but living up to the hype is even better. That's because it's about more than simply envisioning the future. It's about getting there. And here at Mississippi State, we know just the ride to take.
Welcome back. My second guest today is Carl Pittman. He recently graduated from Civil and Environmental Engineering here at Mississippi State, and he's going to be starting his master's this fall, I presume?
I'm starting research this summer.
Starting research this summer, so hot out of the block, so that's great. But you're the captain of the concrete canoe team.
Yes, sir.
And the team has had a lot of success this semester. So tell me a little bit about the team. You know, who's on the team and where are they from? And
The team is made up of any year civil engineering student who's a member of our student chapter of ASC, that's American Society of Civil Engineers. They also have to be a national member. And so it's any age, but typically we have mostly juniors and seniors. The freshmen and sophomores don't really feel too. They don't know that many people on the team yet and everything, so people just get more comfortable, and it's typically juniors and seniors on the team. We have a few freshmen and sophomores though.
Okay, and about how many students do you have on the team?
A little over 20.
A little over 20. Okay, so it's a decent sized team.
Yes, sir.
And tell me about the whole competition. I think of concrete, I think of it as something that you don't typically use to build a canoe. So.
No, sir, and that's the challenge of it. And this is one of our cylinders.
Okay.
And it's made of very specialized aggregate, and you can feel it. A typical cylinder like that would weigh about 7 or 8 pounds of regular concrete. Ours weighs about 1.5 pounds.
It feels very light just holding it, yeah.
And so we use aggregates that are expanded glass beads, and we create a concrete mix design that's lighter than water. Okay. And so this cylinder, if you dropped it in water, would float on its own.
So in the competition, are there special requirements for the concrete and the mixtures that you use?
There's a set of rules that have requirements on every aspect of the competition. The concrete mix design is a big part of it. There's specific things that you can and can't do. Every year they typically change 1 or 2 things. They just tweak the rules a little bit. That's so teams can't just use exactly what they used last year, and creates a little bit more of a challenge every year.
Okay, so you mix the concrete, you pour it into a mold or
yes,
something?
Yes, sir. We have a styrofoam mold that we cut out with the CNC machine that the university has. And so we got a real symmetric mold. and then we mix the concrete and pour it in there, and it cures for 28 days, and we pull it out.
And then tell me about the competition. You have to go a certain distance, or?
There's 4 aspects to the competition. There's a design report that we have to submit, and it's 25% of your score. There's a presentation at competition, that's 25%. There's a product display, that's 25%, and then the races are 25%. So while the races are what everybody thinks about, they're actually only a quarter of your overall score.
So this presumably is good preparation for becoming an engineer and actually going out and practicing as a professional engineer in the industry.
Yes, sir. It's been very helpful.
So what are some of the biggest things that you've learned as a result of being on the team?
One of the big things is the difference between what you plan to happen and what actually happens. A big example of that is theoretically our canoe was supposed to weigh about 200 to 220 pounds, and it came out 320 pounds.
Okay,
So
I can see how that would be a challenge.
Yeah, it's hard to control the thickness when you pour it, and that's what happened. Is we had some spots that were the thickness we wanted, and then some were too thick, and it just led to a heavier canoe. So that was probably the biggest thing. Is it can say on paper that it's going to be ½ inch thick, but then in spots it may be 3/4 of an inch, and in spots it may be 1/4 of an inch. So that was a big part. A big learning curve.
Yeah, and so you won at the regional competition this year, and so the next stage is the national competition?
Yes, sir. Going to nationals in Golden, Colorado.
Okay, how do you think you're going to do?
The competition's pretty tough there. They have about 4 or 5 schools that have very light canoes, which helps you out a lot in the races. But again, that's only a quarter of your score, and I think we have a pretty good report and presentation, and good-looking canoe, which is a big part of it too.
Yeah. Well, I wish you all the best. I hope that you come away successful from the national competition. I think it's great for the university to get this sort of publicity with the great things that the Concrete Canoes team is doing. So thank you for being a guest here today, and all the best.
Yes, sir. Thank you.
That's about all we have time for today. We look forward to you joining us again next time.